Welcome, everybody. Thanks for joining us. Installment 4 B2K webinar session. Thank you very much for joining in. So, what are we doing this month? This month, guys, we're going to keep an eye on it. And if I'm saying keeping an eye on it, I mean we're going to be monitoring. All right. And we're very proud to be able to have launched our condition monitoring with the Bearings 2000 group. And this is all very exciting. So, I think we are moving towards a platform where, rotating expertise just on another level. All right, so if we just have a quick look at what it is we're going to be going through today. And I'm going to try and keep it short and sweet, guys. At the end, you'll have a nice email address there. You guys have got your account manager's contact details. If not, you send an email through to training@brg2k.co.za, and we will be able to assist in anything. So this is not an in-depth session. This is not going to be the ins and outs about the condition monitoring. This is going to be keeping an eye on it and what it is that we will be able to do going forth from here. All right. So let's just have a quick look at our objectives. Right. So for those of you that are new, sorry, guys, I ask that if you are in, please just mute. For those of you that are new to my webinar sessions, right, we just kind of have a little look about B2K and the B2K Training Academy. And then we're going to look at why monitor, basic condition monitoring, guys. And if you see the word COMO throughout my presentation, that is just short for condition monitoring because I ran out of English when I was doing this. All right. So basic condition monitoring concepts, we're going to look at visual inspection, sound inspection, vibration inspection, entry-level condition monitoring, and of course, advanced condition monitoring. So going back and looking at Bearings 2000, who are we? What do we do? Well, we were founded over 30 years ago, and we are currently an independently owned bearing company. So if it rotates, you talk to us, okay? Currently over 50 employees, 7 locations nationwide with 3 hubs in the big regions or in the main regions, Johannesburg, Durban, and of course, Cape Town, all right, with a comprehensive product range of bearings, power transmissions, and seals. Large stockage, and of course, we believe and we believe that we are industry leading within the service. Right, now, my little baby, the B2K Training Academy, right, we launched in February of this year, and it is aimed at the end user maintenance teams. Right, because there's always this endless battle between maintenance, operation, and production. Well, at the end of the day, we fall under the maintenance. So we are looking to increase your uptime to get the most out of the rotating equipment, extend the bearing life that you purchased from your friendly Bearings 2000 store, and of course, form a partnership instead of a customer supplier between end user and Bearings 2000. Right, so what is machine condition monitoring? And if I was doing this in front of a class now, I'd have people put their hands up but unfortunately, I'm looking at myself in a small little window over there, so I'm just going to do it my way. All right, if you look it up and you Google it, Wikipedia says that condition monitoring is the process of tracking condition parameters in machinery to identify possible significant changes which may suggest a developing fault. Now, that is a mouthful, right? So if we just simplify it for people like me, we say condition monitoring is a proven method of determining the running condition of machinery, and it enables us to detect, prevent sudden and disruptive machine failure. So basically, we are looking at the unit, we are listening to the unit, observing what the unit is telling us back, and by that, we are identifying problems and rectifying whatever it is you need to do. So why monitor? A lot of guys will say to me, but I've been doing this since the 1950s. We never had condition monitoring. You know, I listened to it through a screwdriver. There we go. There's my screwdriver. I listened to it through a screwdriver. Yeah, that's right. But if we're looking at why we need to monitor, condition monitoring enables us to repair enables us the repair of the components prior to failure. So we are looking at being proactive instead of reactive. And today we do sit with a lot of people out there that's got the mindset of a run to failure and not actually looking at what that is the cost of that would be, because now we got unplanned downtime, we got unplanned maintenance, and the people say, yeah, but the people already work for me, I pay them a salary. Yes, you do. But when you put those people on the job, whatever you are paying them, divided into their hourly rate, that is what this breakdown is costing you. All right. We want to reduce the possibilities of catastrophic failures. We want to be able to better the availability of replacement parts. So if you do the monitoring and you see, well, hang on a minute, I'm getting to a point where machine A and bearing C needs to be now replaced, but my availability is 6 weeks or 4 weeks, or there's no bearing in the region, or whatever the case may be, we can now plan for that and say, okay, so I know this is the level of the machine. We are going to have a shutdown in 4 weeks' time. So your availability of replacement parts will be a lot better. You're able to schedule your manpower a lot better as well. And then, of course, proper planning for repairs during downtime. I'm going to be down, so let's do this, let's do that, let's look at this, etc., etc. Okay. So everybody knows that a bearing is at the heart of rotating, and there is nothing at your facility that doesn't rotate. Anything that rotates needs a bearing. All right. And if you've been with me throughout the last couple of webinar sessions, you would know we did the back to basics. We did the lubrication as well. What the bearing is there for, it is there to reduce the friction within mating or the components of your machines. And for that, we look at the lubrication, we look at the load, we look at the friction or the heat generated, misalignment. We just get my little laser pointer, misalignment, mechanical looseness, and of course, unbalance. All of those elements over there play a role in making this bearing survive, getting the optimal amount of rotations out of this unit so that we know that we've got reduced running cost, we've got uptime, and we've got production. So what does make an effective condition, or what does an effective condition monitoring program look like? Guys, it gets broken up into multiple segments through multiple companies. When we look at us at Bearings 2000, what does our condition monitoring program look like? Inspect, detect, analyze, and repair. That's the way that we look at it, and that's the way we want to implement it and put it across to you guys, right? Inspect, if we say inspect, we're looking at visual inspection, sound inspection, temperature, and lubrication. When we look at detection, it's vibration. When we look at analyze, it is all the data that we've accumulated over these 2 points over here, and putting it in report and giving the feedback to the necessary people, and then of course actioning that feedback that we received, which is quite important, because I can give you all the information in the world, but if you're not going to action it and provide the necessary feedback in terms of what has been done, what is being planned to do, then of course this whole program will fall apart. So looking at the first one in inspect is visual. Visual inspection is not just the tools that you're seeing currently on the screen. Visual inspection is everybody on site that looks around for oil leaks, hydraulic leaks, loose bolts, noise, anything that is out of place. Right, and then what we do is we use the tools at our disposal. This is 2022. The tools are there to make our lives better. Right, so something like a stroboscope is a visual, and I'm going to show you the next clip now where they just got a rotating CD and we slow it down. That is one of the best tools to have on site because you can't always shut down. If you want to be able to visually inspect something while it is in motion, you use something like a stroboscope. Then we've got your tachometers over here. Tachometers is just to ensure that, hey guy, my speed is supposed to be 1480. You put a tachometer on there, you're getting 1300. Why am I getting 1300 RPMs out of this motor? Maybe it's misaligned, the bearing is taking strain, that is upping the energy or increasing the energy consumption or whatever the case may be. That also forms part of the visual inspection. That is an electrical discharge detector. Also vital in terms of the amount of energy consumed or leaked on your site. How do I detect that without getting the people that's charging me $1,500 an hour or whatever the case may be, without getting them on site? What can I do to be able to see if there is in fact a problem? So something like that. And then of course an endoscope. Not the same type of scope as what the doctors use, but the same principle on that. All right, so an endoscope, looking inside of a gearbox, looking inside of a fan cowling or something like that. So we got to snake in a little camera, have a little HD screen and see what's going on the inside. Right, so that is all on visual. And if you look at the stroboscope, for instance, and I put this one in there because I really do love this. Sorry. And you'll see as it's rotating and as the strobe, it's almost like a timing light. Basically, it's making the disc look like it's standing still. And by doing that, I can now actually see, well, if my S was broken, I can actually see, well, my S is broken now without stopping the machine. Right, so visual inspection, extremely important, and it starts at home. It starts in your maintenance team. It starts with your operator. With them being vigilant and just being aware of their surroundings. Right, sound inspection, of course, what a lot of people do have is mandatory earplugs when you go on site. I know noise is, of course, a very crucial part of the health and safeties. All right, so if we're looking at sound, this one over here, we're looking at a electronic stethoscope over there. So that just amplifies the noise into your noise cancelling headsets over there. Over there is a noise meter that actually measures the amount of noise emitted into the environment. So if you've got a certain decibel limit, which some factories are limited to the amount of noise they can put out, perfect tool to be able to just identify where is the high noises within your area. Right. This one over there forms part of sound, not so much the rotating side of it, because that is a ultrasonic leak detector, and that actually is used to detect leaks within your compressed air system. But once again, it is a unit that does do sound. Very nice unit as well. And all these guys, all of these, if anything of one of these, is of interest to you, or you feel like, you want to know more about it, you'll see the email address at the end. You'll speak to me, you'll speak to your CAM or whatever. We'll send you the information, send you the various options. So just bear that in mind. And we'll take some questions afterwards as well. So we'll get there. We'll get there. All right. So temperature. All right, this one over here, that is a thermal imager. So that is used for thermography. Thermography is a big part of condition-based monitoring. All right, so thermography is a technology for identifying and analyzing temperature anomalies. And you can see on the little screen over there, you'll see whatever this guy's measuring, the various colors on the screen. So the brighter, the hotter it is. The heat radiation distribution from a machine is detected, measured, and visualized as a surface map or an image that can be analyzed. All right. So if I were to take a little picture there now, and I switch off the thermography, and I just take a normal picture, I can actually overlay the two with each other, so that I can now see, okay, so over there I've got a problem, and over there, why am I emitting so much heat? Something is wrong there. Maybe it's a lubrication fault. Maybe there's some misalignment, or whatever the case may be. Okay. Another way of just checking temperatures, and to me, I'm a firm believer that everybody in the maintenance, all artisans, fitters in the maintenance teams should have something like this, infrared thermometer within their own toolbox, so that when they walk around in the plant, they are able to do those little measurement tests, you know. Infrared thermometer senses the thermal energy radiated from an object. These portable tools help you to detect temperature differences in technical and non-technical applications in order to perceive information. All right, so a lot of big words there. Basically, it's a point and shoot. So the old thermometers, you've got a nice little gauge, and you've got this probe, and you've got a little wire, but now you've got to start sticking your hands into dangerous places to have pinpoint accuracy on your temperature. So this is like 90% of those little COVID guns that we've all gotten used to for taking your temperature when entering a shopping mall or a store or whatever it might be, except, of course, this is more advanced in terms of the distance that it can detect and the angle, and, of course, the way that we utilize it and store data. All right? It's a very, very nice tool, guys. Once again, this is part of the inspection side. Right, lubrication. So about 2 months ago, we had been greasy, and we did all about lubrication. What is a lubricant? How does it get made up? And what do we choose? Why do we lubricate? How much? When? And to tell you the truth, I'm not going to, this is not a course about lubrication. This is not a webinar about lubrication. This is about condition monitoring. And your lubrication forms part of that condition monitoring. Okay, because if we look at it, numbers don't lie. 50% of all premature failures are due to either poor lubrication or contamination. Now, if you've got an oil-based system, easy. Everybody always checks the oil, has the oil sampling done. The oil goes through a filter, it goes through a cooling, and. But we got to know that 80% of all bearings are grease lubricated. So why are we not checking that? I know some people go, yeah, I just rub it between my fingers like that. Yeah, if I feel any grit, don't worry. No, we change the grease now. Yes, no, maybe, sometimes. Lubricant analysis is vital part of predictive maintenance. Okay. Until recently, however, oils were almost analyzed, despite the fact that around 80% of bearings are lubricated. Yes. So, excuse me. So if we look at this little kit over here, this is, I don't want to use the word DIY, but it's basically a kit that you can have within your maintenance team arsenal, and it's very extremely easy to use, where you would detect impurities, or you would detect the viscosity breakdown or the consistency breakdown within the current grease within the application. If not, why not? That's my question, you know. No, don't worry, I'll put some, just put some grease until it pours out the seals. No. Unfortunately, that's not the way to do it. This one over here is just a little oil checker. Extremely easy. You put a little bit of the fresh oil within the container, just on that there, then you clean it up, then you put the used oil on there, and it just detects the difference. It uses the baseline, it detects the difference, and it lets you know if there's any wear particles or something in there. So that forms part of the inspect, is of course lubrication. Right, detect vibration. So when we look at vibration, and once again, this is not a vibration analysis webinar, so I'm not going to go into stuff like enveloped acceleration, velocity, and all those type of things, but we're going to have a brief overview of vibration. So when we take or listen to a machine, whether it is with the stethoscope or with your trusty uncalibrated screwdriver, our ears picks up a noise. The noise is the noise. And I always like to compare it to my dogs. I love my dogs very much. And I've got a nice boy German Shepherd. And they are set in terms of their hearing, but also the vibration. Because when I start driving up the road, my dog's at the gate. He knows dad's home. But any other car comes driving up the road, well, he just lies there. And so they detect those small noises with those tiny little hairs in their ear like vibration. And it's the same when we look at rotating. We need to understand what's going on the inside. Each bearing emits a different frequency depending on size, roller geometric, whatever the case may be. And we all just hear one thing. But when we look at it, it gets, with the vibration and the collection of vibration data, it gets split up into all the various sections that we need to understand. The spectrum analysis shows the data signal to be separated into individual frequency components. Now, using the words spectrum analysis and frequency and all that, yes, if you're not into condition monitoring, or you have not yet worked with condition monitoring and vibration, it might be words that scare you, but it's not. It is fairly straightforward. Okay, so we are looking at vibration and taking that vibration data, pulling that spectrum apart and saying, hey, Frikkie, your bearing is going, or hey, Koos, listen, guy, you need to do alignment on this machine. All right, and all of that gets basically conveyed to us through looking at the data. Right, so if we look at the, okay, that's not right, but I'm sorry for that. If we look at the cost of production versus time to failure, all right, and this is where we are currently talking about a walk around data collection and analysis, and which is usually sufficient because you can have monthly data and you can trend, and now we start comparing reports with each other. We're having feedback sessions saying, listen, guy, I did do the alignment on this machine. So this month, when we check the machine, just remember that here's the alignment report, you know, so which is critical in making a good condition monitoring program work. Then one step up would be permanent sensors. So it's a sensor that is permanently on there. It is, whether it's bolted or epoxied on there, and that just runs to a junction box. And at any point in time, at any given day, you can just plug into that box and quickly download some data. See whatever it is you want to see and take it from there. All right. The next one would be online surveillance systems. So this is actually then the similar permanent sensors, but now instead of running it through to a junction box or a switch box or whatever you want to call it, this now runs through to your control room. Gets written into the SCADA, you've got it in your control room, and somebody actually monitors it. You can now start putting alarm levels on there, saying if the temperature exceeds 85 degrees, then it just flashes a little light. Now we need to understand why. All right. Then the ultimate goal, of course, sorry guys, I've just got something popping up on my screen here. Just give me 2 seconds. Sorry about that, guys. All right, and the other one, of course, is continuous monitoring with or protection monitor. All right. So what this is, we've got this system now that is into our own database on site. It's in the control room, but now we're putting in protection systems. Now we're putting in stoppages at 14 millimeters per second. I know that's high for those of you who understand, but we're putting in a machine cutout for an excess of 92 degrees or whatever the case may be. Continuous, and then, of course, continuous monitoring also being something that is cloud-based, with somebody continuously monitoring it and looking at the trends, looking at what it is that had happened. Okay, so we are currently looking at this webinar is focused about the walk-around collectors and surveillance or the analysis, all right? But these are all within our arsenals, and these are all, of course, long-term investments. All right. So let's just have a look at what it is that we, and I can remember when I started in this industry about 20 years ago, actually this year, 20 years ago, we used to collect some data down here in Cape Town where the guys would walk around with this big ass box like that, you know, and they've got this big magnet and they're putting it on there, and this box would take like 5 minutes and then it goes, and then it just took a reading. Right. Not anymore, guys. Not anymore. 2022. The SKF Quick Collect sensor, machine health and diagnosis at your fingertips. All right. This over here is an accelerometer and data collector that runs through Bluetooth to a phone or a tablet. Yes, I said it. A phone or a tablet. All right. And this can be used in multiple ways. A lot of you out there remember the old-fashioned pinpoint vibration pen, and you would go there and you would just pin it there, and it would take a quick snapshot reading, and you'd look at the screen, and then you jot it down, and then you go to whoever's engineering manager saying, yes, boss, that one is running 5 millimeters per second. It is running at about 2.4 G's envelope, and 20, it looks like 65 degrees. All right, yes, I get that. All right, we're evolving, guys, we're evolving. This one over here replaces that with a simple app when we look at entry-level condition monitoring. So that is just on the job card. Listen, John, please go to the recirculation fan on the upper level and just go take some data on there. I just want to see what the unit's doing. Now, instead of taking that pinpoint vibration pin, he takes this nice quick collect, all right, and he uses the SKF Pulse, and he opens it up on his phone, and he just jots in there, all right, it's a 22222 bearing. It's running at 1480, and it puts in all the parameters, and it puts it on there, and it gives you live reading. It just keeps on going. As the product comes through, as the air moves through, it just gives you these little, that little arrow over there just keeps going up and down, up and down, up and down, up and down. Now, this is just a screenshot of the velocity. You've now got the velocity, the enveloping, and the temperature all on one screen. It's not very big, but there you can see it. And it's just going up and showing you. And by putting in all that data, it's giving you an ISO standard as to what the unit should be. If I've got a 22222 bearing in there, what does ISO say in terms of the standard to which this bearing can operate at? Right. So it pulls that through and it immediately gives there. And then you just do a screenshot of it there. I do apologize, guys. I'm so sorry about that. You take a screenshot there, and you can even take that and email that little bit of a graph over there. That is entry level that is using it that way. What's nice about these as well is they create little QR codes. So every time you get to your application, you've created the QR code, you've stuck it on there. All right, so you just get there, you snap the little QR code, it brings back all that information. You put your accelerometer on there and you look at your data. Brilliant. What could be better? Now, this could be better. All right. So using that exact same unit, we can now look at the SKF Enlight Pro Collect system, where you can use it as the normal pulse, but you can also use it as a route-based system. Okay, so in terms of that, there is now a set route. You take the data goes to the cloud, you get an analysis, you get a report, you get your feedback session, and it is just a marvelous relationship between Bearings 2000 and the end user. We sit down, we discuss, right, what did we see? Well, I saw that screwdriver's handle wasn't orange anymore. Right. So what are we going to do? Well, we're going to paint it orange again. The next time around, hello, Mr. Customer, just quickly before we take the data, was all the necessary standoff? Yes. That is now orange again. Okay. So if we see something similar, we know that that is not the fault. And now we've got history. We've got collection. We've got data on data on data on data. All right. And we do a lot of guys in the Western Cape that likes to do it monthly. There's some of them that would say, hey, guy, come check out my fans quarterly. So every quarter we would take the data and then compare, and we always ask the question, the main question that we always need to ask, what has changed, right? What has changed? Well, we replaced the motor a month ago. We lost the coupling and we changed the coupling, or we went from a spider to a tire coupling, whatever the case may be. So that all forms part of this. And once again, guys, I'm not going to go in depth with this. We're not going to drag this out too much. This is all based on your needs. So for me going, we've got some food and beverage guys in, we've got some mining guys in, and it doesn't help we all talk on the same level, because while the mining has got a hell of a lot bigger bearings than what the food and beverage industry has got. All right, so you contact us through the training at brg2k.co.za. We'll put it up again at the end, and we discuss and we get someone out and we sit down and we form a plan. Okay, right, so let's continue. Almost there. Right, so that's what the little quick collect looks like. There you can see she put it on there. The SKF Collect handout unit, all right, with the Pro Collect in terms of, there's the Pulse app and there's the Pro Collect app. So that is a route base, of course, with storing data. And then, of course, whether it gets sent to the cloud for immediate analysis, whatever the case may be, that all depends on what we implement on site. Good. Right. So there's just a little picture. Don't run away. That's just a little picture of the spectrum that would come from these little units over here, with the amount of resolutions, and then of course we'll break it down. But once again, that is for the analysis. Over here, you can just see that the monitoring points would be radially and axially. Sorry guys, give me 2 seconds here. Okay. All right, so if we now look at the Bearings 2000 condition monitoring options, we've got the customer driven one and we've got the B2K driven one. All right, with the customer driven one, we're looking to supply the relevant tools and the training thereof and implementing a quick collect program. That is assisting with the QR codes, assisting with putting in the information and all that. And now you use it on site. Customer driven, so your maintenance team does it, your operator, your engineering manager, your mechanical foreman, whoever, you can have the accountant do it. That is actually how simple it is. All right. But the information that gets retrieved is extremely vital. Okay. Then we look at the Bearings 2000 driven one, which is managed and run by Bearings 2000. Right, so the data collection and reporting would be held by Bearings 2000. So we would look at the route-based options with monthly feedback sessions if you request to go on a monthly route-based analysis plan, or whether it be 3 monthly or whether it be once off. But just know that we as Bearings 2000 are there to help. We are there to try and optimize the rotating with all the bearings, of course, that you purchased at your friendly Bearings 2000. And we're trying to get the maximum life out of these. Okay, so the program, along with the rotating expertise of Bearings 2000, will result in your increased productivity, reliability, availability, durability, and machine uptime. Decrease your energy consumption, your heat generation, wear, noise, downtime, expenses, contamination, and consumption. Right. So we are very proud to be launching this. And as I said to you in the beginning, this is not a full-on, in-depth, let's look at the spectrum and let's pull it apart. This is just to make the product as well as the service known to you guys and what it is that we actually do. So all of the tools that you saw with visual inspection, with sound inspection, and detection is available through us, and we are more than prepared to assist you with selecting the correct unit for the correct application or what it is that you're trying to do. But up until then, you guys need to feel free to contact us. So at this point in time, guys, that concludes the slide section of this presentation. I will be taking some questions. If you guys do have questions, if you want to talk to us on a different level or personally, you will pop the email through to us with some contact details, and I'll get back to you ASAP. But if the chat is there, guys, if there's anybody that has any questions, please feel free to do that now. Right, and I'm just going to put that email address up there for you. There we go, training@brg2k.co.za. All right, no questions today. Not a problem. Pop me an email. Also, guys, when you do get a chance, go check out the blog on our website. We've got some lovely feedback there in terms of training sessions that was recently held up in Joburg. And then, of course, a lot of the details surrounding some of the products, some of the services, and is on there as well. Also, go on to LinkedIn and go and like our page or follow our page as well, Bearings 2000, where you'll automatically get all the updates and all the newest posts and what is happening. There was actually a very good one, guys. Go look at it. We just celebrated Youth Day. So that was nice. Go have a look at that one. I'll take it if there's no questions. Guys, also, we will be sending out a mail when these presentations get put onto our YouTube channel. Up until then, I thank you very much, and I wish you a good month forward until we meet the next time round with the Bearings 2000 webinars. Thank you so much for joining, guys.
Thanks, Wynand. Thank you. Cheers. Bye-bye. Bye-bye.
Thanks, Wynand.